Welcome to Spring LIB.
Hi, let us look at this situation. So we have a circular disc and a rod is attached with a pin to its circumference. Let's call this point B. And there is a collar D attached to point B, which is in line with the rotating wheel. So this rod is going to attach to this collar D, which can move vertically on this. So the motion for collar D is only going to be along vertical because of this rod on which the collar moves. Okay, and this disc is fixed with an axis and it's rotating. Um, in this problem, it's rotating with omega clockwise 15 radians per second. Now, this angle which the point B makes from vertical is theta, and the length of rod BD is 10 inches and the radius of circle is 2.8 inches. So then we are asked what is the velocity of point B, what is the velocity of collar D and what is the angular velocity of rod BD for different values of the angle theta. So let us try to solve this problem for a general theta and then we can plug in the values of theta and get our answers. So like in any of these problems, you want to break this motion into translation plus rotation. But let's first look at the net motion at the point B. So if this is our rod BD and this is sitting on circumference of the circle, then the motion of point B is basically the radial velocity of this disk. So it's going to point in this direction, perpendicular to the rod. So radial velocity is always perpendicular to the radius. So this is the radius of the circle. So it's perpendicular and it's pointing this way because angular velocity is this way, because radial velocity is always omega cross r. So the value will be here 15 radians per second times 2.8 inches. So this will be 15 8s are 120 and then 15 2s are 30 plus 12 42 inches per second. Okay, now this is the net motion and the angle it makes from vertical is theta. So what about the translation and rotation motion of rod BD? So let us first write down the rotational part. So for rotational motion, let us assume B to be our axis, which is, let's call it fixed. And let us assume an omega. And as I said, if you assume in these problems wrongly, then the omega you get is negative and you always get the correct physical picture. So let us assume that the angular velocity is, let's say, clockwise. In that case, the angular velocity at point D is going to be pointing like this, and then the magnitude will be omega times 10 inches because that's the length of BD, and the omega will be omega BD, which we don't know yet. Okay, now, so most of these problems are basically problems of geometry and trigonometry. So the biggest part of the problem is to figure out all the angles. So if this angle is theta, the angle rod B is making with vertical is theta. Then if we bring this vertical here, then this is theta. So since this is 90 degree, this is going to be 90 degree minus theta. And since this collar D can only move along vertical, so the component of this omega times 10 along this direction is what is going to give D its velocity, and the other component needs to get cancelled, and this is going to be cancelled by the translational velocity. So the translational velocity, now from this figure we can figure out that it's going to point along this direction. Let's call it Vt, and by definition of rigid body it's the same for all the points. So even at point B, now we have the velocity Vt, and so this Vt is coming from this velocity. So let us figure out angles here as well. So the angle B makes from vertical is theta. So the angle, if we bring this vertical here, this angle is going to be theta, and since this is along horizontal, this is going to be 90 minus theta. So, and this is going to be theta. So now we know that if we break Vt along these components, sorry, we don't need to break Vt. Vt is a result of the angular velocity, result of the radial velocity of disk. So we need to actually break this guy along Vt. So if we figure out the angles here, since this angle is theta, this angle is also going to be theta, and if this is our horizontal, then this is going to be 90 degree minus theta. So this angle is again going to be theta. So since these two motions at point B are giving rise to 42 inches per second, if we break this 42 inches per second along this theta, then this will give us our Vt. Okay, so we get one of our equations. Sorry, scroll too far. Yeah, so at point B we get 42 inches per second cosine theta equals Vt. That's equation 1. And then if we look at point D, at point D we know that the velocity of point D is going to be only along vertical. So there are two equations here. So velocity at point D will be equal to, let's write this next. Let's first write the horizontal component. So we know that horizontal component has to cancel because D is restricted to move only along vertical. So at point D, Vt has to equal omega Bd times 10. And what is this component? So this was 90 minus theta. So this is theta. So this is omega Bd times 10 cos theta again. So this is second equation. So, and then finally, velocity of point D is going to point along vertical. And let's actually write down Vt first, because from this equation we can get Vt. So, and then we can take care of vertical components, which will give us velocity of point D. So from 1 we get 42 inches per second cos theta equals omega Bd times 10 cos theta. Cos theta gets cancelled and we get omega Bd as 4.2 inches per second. So it turns out that omega for all angles is the same. So for this is for theta equals 0, 90 degree and 180 degrees. Now the next part asks us velocity of point D. Velocity of point D is going to be the vertical component. So it's going to be omega BD 10 sine theta. So for different, so let's put these numbers in. So if you put this omega here, you will get 42 inches per second sine theta. So this is your VD as a function of angle. So now if you put different angles, so for theta equals 0, VD equals 0. For theta equals 90 degrees, VD equals 42 inches per second. And then for theta equals 180 degree, VD equals, again sine pi is 0, so this is again 0. So you can see that as the disk rotates, the velocity is going from 0 to maximum and then again 0. So the next problem just discusses this problem again, and it asks that if disk has a constant velocity of 20 radians per second clockwise, then determine the two angles theta for which the velocity of collar D is 0. And for these values, determine the angular velocity of bar BD. So we don't need to solve this whole problem again. So, and since I don't want to write down and solve for everything again, I will just solve this problem in this part itself because we have solved it for general case. So in this case, the omega is for the disk is 20 radians per second. And if omega is 20 radians per second, then the only thing which will change is basically the V equals omega cross R. So this will now be 20 times 2.8 inches, 20 radians per second. So this will become 56 inches per second rather than 42 inches per second. Everything else remains the same. So omega BD, as we figured out, this was going to be independent. So for both the velocities, the angular velocity will still be in the case above, we found it 4.2 inches per second. So analogously, in this case, we will find it 5.6 inches per second for both cases, both the thetas. And what are those thetas at which the velocity of point D is 0? So theta at which VD equals 0. So as we figured out, it was sine theta. So theta will be 0 and theta will be 180 degrees. So at these points, the velocity is 0 and omega is going to be the same for both points. So I have solved both problems by just solving it in a general form. So next answer and this answer are going to be the same.